Hi, this is Darren with the Mississippi State Chemical Laboratory, and today I'm going to show you how we measure pH. So we're going to start with some basic electrode maintenance and then do a calibration for our pH meter, and then we're just going to measure some pH of some water samples we have. After that, we'll do a little bit of discussion on the theory behind it. So here's our pH electrode setup. One of the first things you'll notice is that our electrode is in some electrode storage solution. That's a very high concentrated ion solution. So before we do anything, we need to take it out of that, and then we want to rinse off our electrode. We're just going to do this with deionized water. Rinse off any of that electrode storage solution that would be stuck to the end of it. One thing that you want to remember is that you don't want to actually wipe this down with like a chem wipe or a paper towel, because that could introduce a static electric charge and mess up your reading. So we're only just going to rinse this with deionized water until we think we've got it. Another thing that's really important for pH electrodes and other electrodes is that we want them to be in a wet environment at all times, and so when we're not using this, we don't want to let it just sit out, or else it'll dry out, and that can ruin the electrode also as well. So before we can measure pH, we are first going to have to calibrate our pH meter and then check that calibration to make sure it worked okay. So we have these buffers. This is our pH 4 buffer. We have a pH 7 buffer, it's yellow, and our pH 10 buffer is blue. In addition to these, we also have this pH 7.4 buffer, and that's what we're going to use to check to make sure our calibration was okay. The first thing we need to do is, on our pH meter, choose pH, and you can see here it has a standard curve in there already, but that was the last one. We want to change out our buffers at least once a week, and we need to calibrate the pH meter every day that we use it. So this is an old calibration, so what I am going to do is hit standard and then clear to clear the previous calibration. And you can see now that calibration is gone and it says not standardized. So I'm going to start with the 4 pH, then work to the 7, then work to the 10. So I'm going to take my 4 pH buffer, put my electrode in there, and then you want to have a little bit of a swirl going to make sure that it's well homogenized. You can see on the screen the pH was fluctuating a bit and then it went to stable. So then we want to press standard and then enter our 4 pH. So it now has that point at 4. In between our buffers, we need to rinse our pH electrode. So I have my deionized water again. Just give that a good rinse. Kind of shake off the excess water, and then we'll move to our pH 7 buffer. You can see already the measured pH has gone up near 7. So we will hit standard again. Wait for it to go stable, hit standardize, and then enter 7. Okay. Rinse off our electrode one more time. Shake off the excess water and switch to our pH 10 buffer. Going to let that stabilize. Takes a few seconds. Okay, then hit standardize. And hit it again. And then enter 10 pH. Okay. So that's good. It's giving us a slope of 97.0. If the calibration didn't work well, it will sometimes pop up an error message and say that it's out of all out of whack, but it didn't give us that this time. So what we're going to do now is just check with our pH 7.4 buffer. Now ideally, we want this as close to 7.4 as possible. We usually see it anywhere between 7.3 and 7.5. So right now it's coming in at 7.32, and that should be fine. So again, I'm going to rinse off my pH electrode, and then before I leave, I'm going to make sure I put it back into the pH electrode storage solution. After we calibrate, we want to record in our logbook what we're doing today. So this is going to be analyst, me, date is April 29th, 2020. We calibrated the pH meter. Average slope came in at 97.0. Okay. Our pH 7.4 buffer was reading at 7.32. And then what we did today was video training. Two water samples. That's it, and now we're ready to measure. So we're going to measure some samples now on our pH meter, and this is about as easy as it can be if it's been calibrated correctly. To start, we're going to remove the electrode from the storage solution again. Rinse it off with some deionized water. Try and not block the view. Okay, and then I have today just some water samples. These are actually just the laboratory's own tap water, and then also our deionized water from our DI system. If we had solid samples, our typical method is to put 5 grams of solid in 20 milliliters of water and then let that soak for at least 30 minutes. Stir if necessary, and sometimes with certain samples that are particularly absorbent, we'll need to add more water, just at our discretion. But in general, 5 grams of sample in 20 milliliters of deionized water, and then we're ready to just measure straight out of the beaker that's been soaking in. But for now, we have our water samples. So this is our deionized water. We can see what pH that comes in at. Some people are surprised when they see this. They expect the deionized water to come in at exactly 7, but it usually shows up on the acidic side. So you can see right now our pH meter is reading in the 4 range, 4.71, 4.69. We're going to do this until we see the pH is stabilized. Now, one thing to note about pH is that it's an intensive property, so it doesn't really matter how much we have. Right now we've got a 50 milliliter beaker of water that we're measuring. We could do this in a 1000 milliliter beaker, for instance, or maybe even a 25 milliliter beaker, and we should get the same results because the pH is a function of the concentration of hydrogen ions in the solution. That said, you can't go too small because you need to be able to submerge the end of the electrode. So I usually opt for anywhere between a 50 and 100 milliliter beaker, just for ease of use, but also to make sure that it's functioning properly. So you can see the pH meter actually counted itself as stable for a second. It made the beep, but then it kept moving. So you want to make sure that it stays stable for a good amount of time. Alright, that water's coming in at around, oh, now it's going up. We can edit this out in post, probably. There we go. 4 point, oh, come on. I could be sabotaging myself by speaking over this because one of the things that can happen is as I breathe out, the carbon dioxide that I'm exhaling gets absorbed into the water and converted into carbonic acid. And so maybe I should just be quiet for a minute. Alright, I'm going to call it at 4.5. Maybe I'd write down 4.51 for that. Deionized water is always kind of tricky because it is so low in concentration of other things. What we will often find with our samples is that they will get to their final pH quickly and stay there. But there's really no buffer action going on in the deionized water. Let's check the tap water and see how that goes. So already we're seeing the tap water comes in with a higher pH than our deionized water. What you might also notice is what it's actually measuring is down here. Oh, I don't actually, it's out of frame. It's the millivolt reading off the electrode, and then it's using that to convert to this pH measurement up top. Interestingly, they are almost inversely related, where right now, as the pH is increasing, I'm watching the millivolt reading decrease. But occasionally you'll see the pH reading not moving, but it still isn't counting as stable because the millivolt reading is still moving. And that usually happens toward the end of it. You just got to wait for the beep and the message that counts it as stable. There we go. That, I'm gonna say that came in right at 7.00. So our tap water is actually pretty close to neutral pH, whereas our deionized water is much lower. Anyway, that's it for this measurement. So we can take that electrode out. Once again, rinse it off with our deionized water. Shake off the excess. And since this is the last measurement I'll be doing today, we'll put it back in our pH electrode storage solution. So now that you know how to measure on our pH meter, I wanted to talk a little bit about how it works and what it all means. If all you came for was to learn the procedure, you can safely click away from the video now, but if you want to learn a little bit more, stick with me. So, what we want to know when we're looking for pH is actually specifically what is the concentration of hydrogen ions. The P function is actually a more well-known function that can be applied to other things, but in this case we're applying it to our H concentration. The P function is just the negative log of whatever we're looking for. And so in this case, pH is the negative log of the hydrogen ion concentration. Now you don't really need to know this for our purposes, but the main takeaway is we're using pH as a way to measure how much hydrogen ion there is in solution. So the way the electrode works, and this is maybe my basic understanding. So we have this glass electrode. Inside of that is a metal electrode. And surrounding that metal electrode inside that glass tubing, we have a solution with a known concentration of hydrogen ions. When we then put that into a solution in a beaker, for instance, that has our unknown concentration of hydrogen ions. The glass in the electrode actually has certain metals embedded in it, and over the course of time, these hydrogen ions are going to gravitate toward the surface of the glass and exchange with those metal ions. Not only is that going to happen inside the electrode, but it's also going to happen outside of the electrode too. So these metal ions are going to go touch the glass, exchange with metal ions there until they reach an equilibrium. What our electrode is actually measuring, as the name implies with electrode, is the electric voltage, or the voltage difference. If you think about what is happening here, we have ions, which are charged particles, and they're moving. So charge that's moving is basically electricity. And by measuring the difference between how much movement is happening in here versus how much movement is happening out there, that's what gives us our millivolt reading. And since we know the hydrogen concentration in here, we can use that to then calculate the hydrogen concentration out here. Now, of course, we're not doing these calculations, excuse me. The instrument itself is doing all those calculations, so to us, it's as easy as just taking the electrode, putting it in solution, and then waiting for it to equilibrate. This sort of gives insight on two of the things I mentioned earlier, which are, one, you don't want to leave this dry and allow it to dry out, because if you allow the inside of this to dry out, then you no longer have your known concentration of hydrogen ions in there. And two, you don't want to wipe your electrode down with a chem wipe because it could introduce a static electrical charge. And since all that we're doing here is really measuring the electricity, introducing that static electricity is going to interfere with giving us accurate readings. That's about it. Thanks for watching my video on using our pH meter to measure pH. I hope you learned something. Have a nice day.